Okay, good morning. This is a tutorial video on kinetic and potential energy worksheets. Just in case I am out one day this week, I thought I'd make this video, and this is what y'all will be working on in class. So the first problem, just follow along and work these out as I work them out, and then I will give you several to do on your own for homework or for the remainder of the class period. You serve a volleyball with a mass of 2.1 kilograms. The ball leaves your hand with a speed of 30 meters per second. The ball has kinetic energy, and then it says to calculate it. Since the ball is moving, it will have kinetic energy, and then you need to determine how much. So we're going to use the formula for kinetic energy, 1/2 mv squared, and it's just going to be a matter of plugging in. Anywhere you see kilograms, that is your mass. Anywhere you see meters per second, that is your velocity. 2.1 kilograms times 30 meters per second, and then we're going to square that. If we square this and multiply by 2.1, that comes out to be 1,890 kilogram meters squared per second squared. And then I multiply that by 1/2. So my kinetic energy is equal to 945 joules. Remember that a joule is a kilogram meter square per second squared. Okay, then we're going to do this next one, number 2, is potential energy. A baby carriage is sitting on top of a hill that is 21 meters high. The carriage with a baby weighs 12 newtons. That's a little bit different than what we've seen. The carriage has potential energy. Calculated. So I want to talk about this newtons here. If you look up here at this equation, the part that I've underlined here in red is the part that you're used to seeing, what I've written on the board. But mass times gravity is also equal to your weight. When you get on bathroom scales, what you are measuring is the gravitational force on your body, on your mass, and that is your weight. And the scientific units of weight are newtons. So a kilogram meter per second squared is a newton. That's your mass times your gravity. So whenever they talk about how much something weighs, they're talking about mass times gravity. So you don't have to multiply that by 9.8. All you're going to do is plug in the 12 newtons. You're going to use the second formula. When they talk about how much something weighs, you will use the second part of that formula, FW times H. So we're just simply going to put in 12 newtons, and we're going to multiply it by 21 meters. And that turns out to be 252 joules, because a joule is also a newton times a meter. All right, I'm going to let you work numbers 3 and 4 and 5 on your own. So let's take a look at number 6. A roller coaster is at the top of the 72-meter hill and weighs 966 newtons. The coaster at this moment at the top of the hill has potential energy. So again, we're going to use that formula, PE equals FW times H, because we're talking about how much it weighs, and they gave us newtons. Newtons is always FW. So that's going to be 966 times 72 meters, which will give us 69,552 joules. If we do significant figures, that would just round to 70,000 joules. Okay, number 8. The potential energy of an apple is 6 joules. The apple is 3 meters high. What is the mass of the apple? Now, I wanted to do this problem to show you how we can rearrange it and solve for a different variable besides potential energy. So here is our equation. We're already told what the potential energy is. Anytime you see joules, that's always potential energy. And anytime you see meters, that's going to be your height. So the question asks us to find mass. So mass is what we're looking for. We're going to do the same thing we've done before. We're going to plug the numbers in, and then we're going to solve for the unknown. So in here I'm going to put 6 joules equals m times 9.8 because G is always 9.8, and then 3.00 meters for my height. I will divide both sides by G and H. So those cancel out. That leaves me with just the mass. And I'm going to have to continue up here. So my mass will equal 6 divided by 9.8 times 3. They didn't leave me a whole lot of room to do this in, but 6 divided by 9.8 times 3. And you want to do the 9.8 times 3 first, which is 29.4. And that gives me a mass of 0.204 is my answer. Okay, so my final answer here is 0.204. Remember, you're going to need to multiply these first, then divide them into 6, and that gives me my answer. So all that stuff about literal equations that we did earlier, this is where we're going to kind of put it into action. If I want to get m by itself, I need to divide both sides by G and H. So m is going to equal the potential energy divided by your gravity times your height, and that's what we had right here. 6, our potential energy, divided by 9.8 times our height. And that unit, of course, would be kilograms. Okay? All right. If you still need to stop and replay that one, that would be a good one to rewind and watch that one again. All right, let's move on then to looking at number 9. 2 objects are lifted by a machine. One object has a mass of 2 kilograms and was lifted at a speed of 2 meters per second. So we have a mass and we have a velocity. The other has a mass of 4 kilograms and was lifted at a rate of 3 meters per second. Which object has more kinetic energy? So what we're going to need to do is find the kinetic energy for both objects. So KE equals 1/2 times 2 kilograms times 2 meters per second squared. And then the other object is 4 kilograms times 3 meters per second squared. Okay, well, 2 squared is 4, times 2 would be 8, and half of 8 is 4. 4 joules for the first object. And on the next one, 3 squared is 9. 9 times 4 is 36. Half of 36 is 18. So the second object has more kinetic energy than the first object. Which object possesses more potential energy when it is lifted a distance of 10 meters? Show your calculation. So the same thing again. We're going to need to find the potential energy of both objects. So our mass is 2 kilograms. G is always 9.8. H is going to be 10 meters. So 2 times 9.8 times 10 gives me 196. And then over here, and I'm not worrying about significant figures right now, This would be 4 times 9.8 times 10. And when we multiply those two together, we get 392 joules. So that's saying that second object also has more potential energy. Okay, one more problem, and then I'm going to let y'all do, I'll tell y'all which ones I want you to do in class on your own. You're on rollerblades at the top of a small hill. Your potential energy is equal to 1,000 joules. So this time we have our energy. The last time you checked, your mass was 60 kilograms. Those are the two things we know. A asks us to find our weight in newtons. Now remember from previous equations written on the front page that Fw, the weight, is equal to your mass times gravity. So for this one, we're simply going to take our 60 kilograms times 9.8 meters per second squared, and 60 times 9.8 gives us 588 kilogram meters per second squared, or 588 newtons. And then in B, it's asking us to find the height of the hill. Now I'm going to work B right here to give myself some room here. MGH, or we could say FWH. We know that our potential energy is 1,000 joules. I know that my force due to weight is 588 newtons, and now I'm looking for height. So if I'm looking for that, I need to get that by itself, so I'm going to divide both sides by 588 newtons. Since I'm multiplying, right here I'm multiplying the 588 by the h, the opposite of multiplying is to divide. So h then will be equal to I think it rounds up to 1.70 meters. Okay, and that's my answer for B. Right. Okay, on C, it says if you're skating down this hill, your potential energy will be converted to kinetic energy at the bottom of the hill. Your kinetic energy will be equal to your potential energy at the top of the hill. So what will be your speed at the bottom of the hill? Okay, so we're going to have to find kinetic energy because ultimately I want to get velocity. I want to know V, but I don't know, the problem didn't tell me what KE is, but it did tell me that kinetic energy is equal to potential energy. So whatever my potential energy is, that's my kinetic energy. So I'm going to put in 1,000 joules right there because potential and kinetic energy are supposed to be equal. My mass was 60 kilograms. I'm not going to use weight in this one because my formula calls for mass times velocity. It doesn't say anything about force due to weight. So I'm going to go back and use the 60 kilograms. And then I'm looking for V squared. Again, if I want to get that by itself, I have to get rid of the 1/2 and the 60. And I'm multiplying those two things. So let's make this a little bit simpler by go ahead and multiplying 1/2 times 60, which would be 30. You can't see my square. So 30 times V squared. Again, if I want to get V by itself, I'm going to need to divide both sides by 30. I'm going to do the opposite. So V squared will equal 1,000 divided by 30, which is 33.3 repeating. But my problem did not say to get V squared, it said to get just V, the velocity. And this is meters squared per second squared. To get just the velocity, and since it's squared, the opposite of squaring is taking the square root. So I'm going to have to take the square root of both sides. When I do that, the square and the square root cancel out, and I'm simply going to, on my calculator, find the square root of 33.3. So my calculator, I'm going to put the square root button, put in 33.3, and then put equals. And that will give me the answer as 5.77 meters per second. Okay, so again, that one was a little bit longer, so take your time, rewind it if you need to go back through, and look at that one again. The ones I would like for y'all to do on your own, you will need to do numbers 3 through 5, 7, 12, which is a really easy one, and 13. Okay? All right. Have a great day. If you have any questions, just message me on Classroom. Thanks. Bye.